Hello and good evening, everyone. I hope all of you can hear me. Uh, could you please send me a note on the chat or just raise your hand to let me know if you can hear me? Please raise your hand if you're able to hear me or send me a note on the chat. Okay, I can see a few raised hands. Let me also look at the... Okay. I think everyone can hear me clearly. Let me still... I can see there are a couple of people who have still not responded. But I guess I'll assume that everyone can hear me. Maybe let me send one chat message to everyone. Very nice. All right, so let me begin with the agenda in mind, whatever we are going to discuss today, and what is the purpose of this session. Okay. Let me move on to the next slide so that we can handle the questions. By the way, in case you are joining here for the first time, I can see there are a lot of old faces, but if you're joining here for the first time, a couple of things that you should note, that in case you have any questions or anything to speak, you can actually raise your hand or even send a note in the questions or the chat module, and I'll be happy to take them. If you have a microphone, you can also speak. If you've raised your hand, I can pass on the speaking rights to you, and you can also speak in the session so that all of us can interact in this webinar. Once again, thank you very much for coming here on time, and I'm glad to start on time as well. The intention is to close it anywhere between 60 to 90 minutes. I hope to close it sooner. But let's try and see how much we can learn from each other from this session. This session is more about teaching Vedic math, the why and how of it, rather than learning about Vedic math. So I'm assuming that most of you are teachers here, and you would want to know how to teach Vedic math. So we are not really going to cover too much of Vedic math intricacies. I'm sure you can Google and find out a lot about Vedic math, how is it conducted and everything. What is more important is, from a teacher's perspective, can we look at how we can make the math part of it interesting to our students. With that in mind, let me just proceed to the agenda. Okay, so since all of you can see this agenda screen here, we will be covering the history of computation. So basically, why is it so important? You know, basically we'll try to cover things which we'll try to see why is this important, how has it progressed, right from the days of the Abacus, and I'm sure most of you would have heard about Abacus and slide rule and so on. We'll try to cover that. What are the various systems of speed calculation? So even though the title of this session is Vedic Math, but I think it's fair enough on our part to know what other methods exist across the world, so that we can also guide our students better. Then, of course, we'll move on to the origin of Vedic math. So basically, who originated it? Did it actually come from the Vedas, as they say, or was there something else? Now, the next point is very critical. Why should you teach Vedic math today? As I said, as I think you would have gone through the email invitation, which said that even in today's world, when we have computers, we have calculators in our mobile phones, why do you need to learn Vedic math? And this is one question your students and their parents might ask you. So we'll try to answer that query. There'll be those references that I have picked up from the internet, mostly from the internet, and I'll give you some references which you can go through at your leisure to find out more about Vedic math and the other stuff that we are discussing. And finally, we'll try a general multiplication method, which as a session ender, I think it'll energize you before you are ready for your dinner. All right, so with that in mind, let's proceed. The history of computation, I have given a link here. Of course, all of this is getting recorded, so you don't have to worry about noting down each and everything here. This is getting recorded, and we should be able to upload everything on YouTube maybe in a couple of days. So in YouTube, when it happens, you can actually go through all the links that are provided here. You would remember this figure, right? Abacus. Now, abacus is something that is quite prevalent even today. There are a lot of educational initiatives and your neighborhood that teaches how to use abacus. Abacus, of course, people might argue that has lost its relevance because of the calculators and computers in our world. But I believe that it's important for our children, for our students to know what are these things, what were these things that some of us might have used earlier. I am not going to deal with abacus in this session because that's something that you can learn on your own using the internet or other places. There's something that anyone who is an engineer here or even otherwise, I believe would have come across this kind of an instrument. How many of you have actually used this? Can you just raise your hands? This is called a slide rule. Have you actually used this in your life ever? I personally am very excited about using this this tool when there were no calculators. I mean, there were calculators, but they may not have been as prevalent at that point of time. Do you remember using this? Any of you? You can just raise your hand and show me that you'd used it. This is called a slide rule, mostly used in engineering colleges. And it's a fantastic tool to actually do all sorts of stuff. So I can see one raised hand. Let me pass on the mic to Devapriya. Devapriya, can you elaborate on what you did with the slide rule? Oh. Hello?
Hello?
Devapriya, have you used slide rule in your life?
Hello?
Hello, we can hear you.
The slide rule we can use in drawing parallel line.
Oh, okay. That's an interesting one. But have you used it for calculations? Have you used it to multiply numbers or find out trigonometric ratios and so on? Have you used that?
No.
I see. Okay. Okay. All right. Thank you so much. Thank you. Okay. So Devapriya had actually used it for. I mean, you can obviously use it to draw parallel lines, of course, with a fixed width in that sense. But slide rules were very popular before the calculators came in, and not just the calculators. In fact, if you most of you would have remembered logarithmic tables, log tables that you would have used for multiplying bigger numbers. Of course, it was an approximation of certain multiplications. How many of you have used log tables? These are all extinct species, math species as to say. Have you used log tables ever in your life? Log tables. Devadatta. Okay. I see one raised hand. I'll just pass on the. Okay, a lot of you actually. Yes, in school. So I see quite a few have used log tables. Let me just pass it on to one of the persons here, and Devadatta is raised hand. What exactly did you use log tables for, Devadatta? Hello, can you hear me? Devadatta? We can all hear you. Can you just tell me what exactly did you use log tables for? Okay, I guess there is some communication problem. Let me pass on the speaking rights to somebody else. I think Smita had replied yes. Let me just see if her microphone is working. Hello, Smita?
Yes, yes. Can you hear me?
Yes, absolutely. Did you use log tables? I guess you used it in school. So what did you use it for?
Basically calculation, trigonometry, etc.
Perfect, perfect. I'm surprised that not even one person has ever used a slide rule, but I guess that's just an engineering thing, maybe.
Probably,
So,
probably, because I'm seeing it for the first time.
all right, okay, okay. Thank you so much.
Welcome.
All right, so I wish I could show you a slide rule. In fact, I had it in my cupboard for quite a while, and I used to love it because it's such a mechanical tool, and you can do a lot of calculations using it. Uh, why is it important to show all of these things to our children is simply because these also give a perspective on how math has developed over the years. People used to use abacus, slide rules, and then of course there were digital machines. And I'm sure most of you know how computers developed over the last decade. And now we have such powerful devices even in our hands. I mean, mobiles have good calculators as well. So that was just just to see how you can excite your children. It's almost like visiting a museum of mathematics. And if you actually go through that link that I'd shown you earlier, you would know what I'm talking about. There are so many other things that you know that people would have used before such fantastic things came into our lives. All right, so let's move ahead. Um, so various systems of speed calculation. I'm sure some of you have heard a couple of these names, not all of them probably. But the first one is a Korean system. I'm sorry, I don't really know how to pronounce this word, but Chi actually means fingers and Sanbop means calculations. So it's basically a finger-based system. And then you have Qmon, which is again a system where Qmon is actually a practice-based stuff, and you can do the philosophy is that you can do a lot of practice, and practice will make you perfect. Abacus, of course, is something that most of you have seen, or probably just now you've seen the photograph. So I will not go into details of Qmon and Abacus, but I think at least for the younger children, if you can tell them that you can actually calculate things using your both hands, I think that would impress them a lot. And some of the schools actually already use this kind of method, but we'll briefly take a look at this. And then there is something which is Trachtenberg system of speed calculation. There are books available in the market, and of course you can Google it and you'll find a lot of stuff on Google as well. We'll go into these details, Trachtenberg, and finally we'll look at the topic of the day, which is Vedic Math. But while we go to Vedic Maths, we must look at other systems as well to know how different is Vedic Math from these, and what are the pros and cons of using Vedic Math. All right, so let's move on. I told you we'll go deeper into Chisanbop, I'm sorry, somebody has to Google it out and find out the exact pronunciation, but let's focus more on the functionality part of it. You can see that you can use two hands, right hand and your left hand. So this particular diagram displays how do you use your right hand to denote 0 to 9. Okay, and obviously I'm sure you would have figured out that the left hand would carry the tens. So basically this system can actually help you do calculations up to 2 digits, so units and tens. Okay, so you can actually put your two hands on your table and try to practice this. With your fist closed, it's 0, and then gradually opening one finger at a time, you get 1, 2, 3, 4. Then comes the big difference. 5 is again your fist closed and the thumb out, and then you follow it up to 9. So this is how numbers 0 to 9 are signified in this system, the Korean system. And then of course using a I think the most critical part here is the number 5. Okay, because this is a slightly confusing unless you get used to it. Number 5 seems like all 5 fingers, but all 5, your hand open would actually mean 9, not 5. So that is one key difference that you would have to figure out. And then of course the left hand. Just wait till your screen shows up the left hand. All right, so left hand actually signifies the tens. So you can see the same thing, 10 added to those numbers. So you have 0 with your left fist closed, and then 1, 2, 3, 4. So these now become 10, 20, 30, and 40. And then again, with your fist closed and thumb out is 50, 60, 70, 80, and 90. So your obviously the maximum number that you can display with both the hands is 9 on the left, that is 90, and 9 on the right, that is 9. So 99 is the highest number that you can play with in this system. That is of course one limitation with the system, but that is good enough. I mean, explaining to a child that they can do a 99 times 98 multiplication using this or addition using this is fantastic. All right, so let's move on. Let's try to look at a couple of things here, and very simply, I would suggest that you should actually try this out yourself right away, so that you get a feel of how this works. So here you're seeing an addition of 27 and 36. Okay, basically it works on the same principles, carry over and all that stuff, but here the limitation is that you have only 5 fingers to play with on one hand and 5 on the other. Okay, so how do you denote 27? Is with your left hand you have your 2 fingers, and with your right hand you have the thumb and the first 2 fingers. So that makes it 27. I strongly recommend that you should actually try it out right now while we are speaking, and I'll wait for you to do it. And I'll also try to do the same so that we're on the same page. So 2, which means the 2 fingers on your left hand, and 7 is thumb and your 2 fingers on the right hand. Plus, now here's a trick. Plus 36. So basically, you have 2 and 3 lined up on your left hand, and 7 and 6 lined up on your right hand. Now the trick is, in fact, maybe you want to do a simpler one first without the carryover. Maybe you want to do, let's say, 27 and 12. So if you want to do 27 and 12, 27 remains like this, the way it is shown in the image. But 12 means that you have only the 4 finger on the right hand, sorry, on the left hand. So the first finger on the left hand, and 2 means that you have 2 fingers on the right hand and the thumb closed. Okay, so this is how it would look like in 1 and 2. And now you can imagine on your left hand you have 2 and 7, and now you need to add 12 to it. So on the left hand you have 2, right hand you have 7. Now, first thing is you need to add those 2 fingers to 7. So you can open the remaining fingers and you get all 5, the whole of your hand open. So that would give you 9. And of course, when you add one more finger to your left hand, you get a 3 finger open. So in effect, you get 3 here, and on the right hand, you would get all 5 fingers open. I mean, 4 fingers and the thumb. So basically, this would mean 39, right? This is how this thing is done. Now let's go back to the given problem. So we are doing 27 plus 36. Now the only issue here is that how do you do carryover? So I know that you've done 2 and 7. I hope all of you are doing this while we speak. 2 and 7 with your 2 hands first, just as it is shown at the top of the figure. And then you need to add 6 to your right hand. Now that's the tricky part. When you add 6, let me just show you how it would happen here. So first one would open your ring finger, second one would open your small finger. So and you remember that this means 9. Now the next step is very critical because you remember that 5 is signified by only the thumb, right? So you will actually close all of these when you're doing the next one. You're going to close all of these except the thumb. So you get 3, count 3, then 4, and then 5, and then 6. So your result would be something like this. You can see here 3, right? Now why is the thumb closed? Because 1 is getting carried over, and 1 goes here as the third finger opens. So you get a 3. I know it can be a little daunting at this point of time, but I guess with some more practice you can try this out. So you get a 33. Okay. When you've added just 6 to it, and then we need to add 3 more to the left hand. So obviously when you add 3 more to the left hand, you had 3 fingers open. So you add 1 more finger, so you get 1, and then you add the thumb, so you get the 5, and then 1 more finger. So all of these closed. So finally you get a 6 here and 3 here. I hope you're able to do this on your own as well. I'll just wait for a second to let you finish the whole thing. Maybe you want to do this again at a later point of time, and we can proceed to the next slide. Now, interestingly, if some of your children or you have an iPad, you can actually go to this appsforkids.net website. The link is given at the bottom. You can actually download this website, and the iPad application will actually show you how to do this. So nowadays everything is available on iPad and iPhones and phones, mobile phones, the Google application and so on, right? Google Store also might have this kind of an application. So that's about the Korean application. Okay, there is one question which says, how can I get 456 into 456? As I told you, this would have its own limitations. Obviously, with this system, you can only go up to 99. I suggest please go through the link that is available. I just shown you earlier. In fact, you can just Google for this finger math way of doing things, and you would get. We'll answer that question. We'll answer that question very soon. But using our own Rupal method, I asked it. Rupal will answer that question very soon using our very own Indian system, that is the Vedic Math system. There you can do 456, 456 times 456, 456. So this too small for that. All right, so let's proceed. Let's move on to another fantastic system. This is called Trachtenberg system. This was developed by a Russian Jewish engineer, Trachtenberg. He was in a Nazi concentration camp, and just to keep himself occupied so that he doesn't fall prey to all the things that Hitler's team might have done to him, he tried to focus on the math part of it, and he developed a rule-based system. There are a lot of things that are available on Trachtenberg system. There is a fantastic book black in color. You will instantly get that book in your Google results once you try to search for this. Of course, Wikipedia gives you a lot of stuff. But one very interesting thing, which is a software which you can download from this link at the bottom. In fact, let me just give you a glimpse of that software while we are at it. Yeah. So let me just open this software. I hope you can see my screen. I'm opening a small window, a small cute window comes up. And I'm not going to get into the software right away. I'm just waiting for you to be able to see my screen. Okay, I guess since this is a DOS-based application, oh, okay. I think you can see it. You can see it. A few of you can see it actually. So you can see that there is a PowerMath main menu, and you can download this free application. This is basically a DOS application, so it opens in the that black window. So I've entered number multiplication, speed multiplication, and so on. There are a lot of sub menus to it, and I think it's taking a lot of time to come on your screen. So I'll probably switch over to the presentation right away. But you can do a lot of calculations using this method. We'll try to do a couple of things here using Trachtenberg methods. So let me just move back to the presentation so that we don't waste too much time on doing this, waiting for this to come up. All right, so we are back on the PowerPoint slide, just in case you're wondering where did that black screen go. This is a rule-based system. It calculates one digit at a time. Of course, all the systems do one digit at a time. No system does 5 digits at a time. But the focus here is one digit by one digit at a time. So the whole difference is that you calculate the units place first, then the tens place, then the hundreds place, and so on. And so let's quickly try to do some simple stuff here. Multiplying by 11. This is a very common way of doing it, even in Vedic Math or any other system that you would have come across. Quite common to every other system. But the rule that it says is add the digit to its neighbor. So let's see how this works. So let's do 47 times 11. Okay. What it says is neighbor word in Trachtenberg system means neighbor to the right. Okay. So any digit to the right of the digit in question is called its neighbor. Okay. Of course, in conventional English terms, neighbor is somebody who lives on your left or right. But here in this rule, we consider neighbor as the guy who is on the right of the person in question. Okay, so let's think about this. Add the digit to its neighbor. Okay. Now, of course, when we are talking about any system, we'll start with the units place invariably. So we are talking about 7. Now 7 doesn't have a neighbor, so we can write this down as it is, 7 here. I hope all of you can see this. And then we move on to the next digit, that is 4. Okay. Now 4 has a neighbor, so the 4's neighbor is 7. So we add 4 to 7, and we get 11. And of course there is a carryover 1, but there is no number ahead, so we can put a 0 here. So 0 plus 1, that is 1, and plus the neighbor, that is 4. So 1 plus 4, that is 5. Sorry. Okay, so this is how it works. Let me explain this again. If I have 47 times 11, what I would do is I would write this 7 as it is because there is no neighbor to it. When I come to 4, there is a neighbor, that is 7. So 4 plus 7, that is 11. And there is a carryover 1. Now, as long as there is a carryover, I need to continue doing it. In fact, I need to cover the whole of it. So I need to have a 0 here. So 0 has a neighbor that is 4. So add the digit to its neighbor. So 0 plus 4, that is 4, and plus the carryover 1. So you get 5. You can actually check this multiplication using your conventional way of doing it. And I hope you'll get the same answer. All right, so let me erase this and do another bit of calculation. Let's try a bigger number. Let's say 2496. 2496 times 11, of course. One inherent question or the problem in your mind obviously is that this is very typical to 11. So obviously Trachtenberg or any other principle, any other system that we talk about will always have some specific rules for specific numbers. This one is specifically for 11. Okay. So let's move on. Let's talk about 2496 times 11. So you know that 6 has to be brought down as it is because there's no neighbor. So 6 comes down as it is. Now 9 has a neighbor that is 6. So 9 plus 6 is 15. And I get a 5 here and carry over 1. Then I get 4, which has a neighbor 9. So 4 plus 9 is 13. Don't forget to add this 1 carry. So 13 plus 1, 14. And I get 4 here, then plus 1 again. And then I again add 2 to its neighbor that is 4. So 2 plus 4, 6. Plus 1, then carry over 7. Now remember, we can't leave it at this. We have a 0 in front of it. In fact, you can add as many zeros as you want. It doesn't matter. So 0 plus 2, that is 2. Now, of course, why I said as many zeros as possible, because 0 plus 0 will always give you a 0, and any leading zeros don't make any sense. So you can actually do away with all these zeros. So the answer is 27456. I hope you got the right answer if you want to check. I would recommend that you also carry a calculator, or you can open your calculator on the PC and keep checking this and point out any errors if I commit any errors. I'm just a human being like you. All right, so let's move ahead. This multiplying by 11, of course, is common to other systems as well. Vedic Math has a very simple rule to it. You simply take down the units place as 6 and keep on adding the other things. So it's very similar to this, except that you will keep getting these numbers, except that the last digit has to be brought down again. So instead of adding zeros, you basically work with the first digit and the last digit and fill up all the digits in between. Of course, taking note of the carryovers that you would come across. So Vedic Maths also has a very similar rule to this. All right, so let's move on. Let's see if there's some more challenge here. Starting from the rightmost digit, double each digit and add the neighbor. Let's see if we are able to work on this. Let me write a larger number here. 4963 times 12. Now this is a bigger number, and let's see how we quickly work on this. Maybe why don't you all try to work on this and then give me a solution to this problem in your chat. Please don't use your calculators. I'm sure you have calculators everywhere. Can you just calculate this and give me the answer? And then we can work on it together. You can also raise your hand in case you want to write it here. You can also raise your hand, and I can give you the rights on the panel. So you can actually scribble your answer here as well. As soon as you get your answer, please raise your hand, and I can, you can just use your mouse and write it here. Please use the same method that we have discussed. The rule is already available on the screen. Okay, there is somebody who has a question. Before I pass on the, okay, I can see that there are a couple of people who have written the answer. Why don't I pass it on, give you the drawing rights. I can see Akshay has given one answer. Akshay, you can actually write down on the screen now, if you want. Do you think you can write it there? You can write your answer, Akshay. I guess your pen tool should be active now. You would see a small drawing tools menu somewhere on your screen. Yes, yes, I can see that. All right. Maybe you also want to speak while doing this. I think it would be better if you can explain how this came across. Okay. Let me activate your microphone. All right, Akshay, can you hear me?
माइक नहीं है, समझाने के लिए माइक नहीं है.
अभी आपका
समझाओ कैसे निकालना.
I can hear you. आपका माइक मुझे सुनाई दे रहा है.
हेलो, कैन यू हियर मी?
Yes, yes, yes. We can hear you. आप बता सकते हैं कि ये कैसे किया है आपने? अक्षय, we can hear you very clearly. आप बता सकते हैं कैसे किया है?
I started from definitely. I have started this taking and make it twice double of that, as we know that we have to double each digit. Here is no neighboring digit to the 3, so it would be
very good. Let me help you by writing down. Maybe you can just speak and I can write on your behalf. It would be easier to write for me. Okay.
You just write. I will be explaining the side. This is 6, and then I move to the 10th digit place by 2. I made it double.
Okay.
And add it to the neighboring digit.
So you get 4 plus 3, right?
3.
Very good.
6. Yes, I got 7. Then I move to the 6. Make it double. And add it to the neighboring digit 2. That it comes out to be 14. 6 to 2, 14. 1 would be the carry. And then make it double to the 9. Twice of 9. 18. Then 6. 4. The total to carry over 4. Double 4 twice, that is 8, which would be added to 9. Neighboring digit 9 plus 2, the carry I got from the previous addition.
Perfect.
That is total is 19.
So I get a plus.
And you get carried neighboring digit 0. 0 into 2 remains 0 plus then 4 plus 1 0.
Fantastic. Very good. Very good. Thank you so much, Akshay. Thank you so much. And I can see there are a lot of other people also.
595.
476. Perfect. Perfect. Thank you. Thank you so much. Okay, so that's how you would get this answer. I'm glad that Akshay could help us out in doing this. And there were quite a few other people also who have given the same answer in the chat window. So I appreciate that. Maybe we can take a. Okay, there was one question. I don't. Okay, Sandeep, but I don't see him here anymore. So maybe you can take his question again when he comes back. All right. So let's move on. Multiplying by 7 is slightly more complicated. I thought we'll go from one level to the second level and to the third level. So let's try and do multiplying by 7. Okay. Now this is slightly tricky. Let's try 3, 2, 4 times 7. All right. Now 324 times 7. So obviously we need to focus on the 324 here. It says double each digit. Obviously we'll again start from the right. It says double each digit, add half of its neighbor. If the digit is odd, add 5. Now the third condition is a slightly confusing one, so we will try to do that here. So double each digit means double 4, that is 8, and then add half of its neighbor. Now half of its neighbor again is a problem when it comes to an odd digit. Okay. So the rule in Trachtenberg is when you're doing something as half, and if it's an odd number, so suppose you're doing half of 7, so half of 7 is 3.5. So we will have to round it off to the lower number. That's a very important rule here. So 3 by 2, 7 by 2 will have to be 3, not 4, not 3.5. Okay, that's the only thing that you need to be careful about. All right. So fortunately for us, in this number there's just one odd number, but let's continue with this. Double each digit, add half of its neighbor. So there's no neighbor to 4, so we will take it as 8. Come to 2, double of 2 is 4, and add half of the neighbor, that is 2, so you get a 6 here. So you got an 8 earlier, now a 6, and then you move on to 3. Now this is an odd number, so how do we treat it? It's double 3, that is 6, add half of its neighbor, that is half of 2, that is 1. And if the digit is odd, now this 3 is odd, so you need to add a 5 to it. So 6 plus 1, 7 plus 5, 12. Now remember, we can't write 12 here as it is. There is a carryover. So you get a 1. And you can precede that 324 with a 0 and again apply the same rule. So double of 0, that is 0. Add half of its neighbor. Now half of 3 is 1.5. We'll round it to the bottom, so you get a 1 and then plus 1 again, the carryover 1. Okay, so you get a 2 again. So your answer, if you take all these rounded digits, is 2268. I hope you have done the right calculation. You can check this and find out if this is correct. Now I hope all of you also know how to check multiplication by using the checksum method. Just as an aside, let's try to do quickly a checksum digit here, checksum method. So 3, 2, and 4, that was the number. So the sum of these digits is 3 plus 2, 5 plus 4, 9. And sum of 7 is of course 7. So I can multiply 9 and 7, that is 63. And of course 6 plus 3 is again 9. I should not have done this because any multiple of 9 will be having the sum of digit as 9 only. So I get a 9. And let's see if our answer also totals up to 9. Okay. So 2 plus 2, 4, 4 plus 6, 10. And 10 is actually 1 plus 0, that is 1. And 1 plus 8, that is 9. So the checksum works. Okay. This is not a 100% guarantee that your correct answer is correct, but very likely so. Very likely so. All right. So let's move on. The slide shows up as very, very untidy, but please excuse me for that. Let's move on. All right. Finally, we are touching the Vedic Math section that was the topic. You would appreciate Vedic Math better when you've gone through the earlier systems that we've discussed, and you would appreciate how different and how effective is this system. I don't think you can escape. It is right to mention Vedic Math without taking the name of the originator or the founder, the person who founded it, person who invented it. He was the Shankaracharya of Govardhan Matha of Puri, Jagadguru Swami Shri Bharati Krishna Tirthaji Maharaj. And this was developed during his tenure at the Math from 1925 to 1960, and he is particularly known for his book on Vedic Math. You can find e-books, the original e-books by him titled Vedic Math. Okay. With that as a preamble, let's move on, and let's talk about. You can see a very blank slide here. I've titled it as base method. Okay. So let's quickly try and do some calculations on base method. Using the base method, how do we do calculations? We don't have too much time available, so I'll do a couple of questions here. Now, what is base method? Base method, of course, is you assume that there is a base that you can calculate. Let's do a quick example, 12 times 13. Okay. Now, if we consider base as 10, now I take base as 10 because that's the number very close to 12 and 13 both. One obvious limitation of this method is that you can't really use this method to multiply, let's say, 12 times 506 because there is no common base to it. But when the numbers are very close to each other, you can take a convenient base and start working on it. Preferably, the base has to be powers of 10, but you can also use other bases once you get very comfortable with the base method. So here the base is 10, and we'll write the deviations here, which means how much is 12 more or less than the base. We know that 12 is 2 more than 10, so we write plus 2. And we know that 13 is 3 more than 10, that is we write plus 3. And then we have two parts to the answer. The important point is the right-hand part and the left-hand part. The right-hand part must have only the number of digits that are available equal to the number of zeros that are available in the base. So number of zeros is just 1 here. In 10 you have just 1 0, so there has to be only 1 digit here. And we'll see how this is very significant. Right now it may not seem to be very significant here. So the right part of the answer will be simply the product of these two deviations. So that is 2 times 3, that is 6. For the left part, you need to do these addition or subtraction, whatever the case is. Either of these should give you the same answer. To 12 plus 13, 12 plus 3, that is 15, or 13 plus 2 is again 15. So you can write 15 here. So your answer is the entire thing, that is 156, and you can check this using your calculators or anything. So base 10, we are seeing one example here. In this case, we have taken an example where it was both a positive deviation. Let's take another example which has both negative deviation. I know all of us know what is 9 times 7, but let's just try and do this for the sake of understanding the method. So obviously 9 is 1 less than 10, 7 is 3 less than 10, and we'll again follow the same method. So minus 1 times minus 3, two negative numbers multiplied will give you a positive number. Minus 1 times minus 3 will give you plus 3, and I can write here plus. Okay, and then you know what to do with this. 9 minus 3 or 7 minus 1, both of them will give you a 6, and 9 times 3 we all know is 63. That's how you get this answer. Okay, now let's do a slightly more typical problem here, where you have a negative as well as a positive deviation. Okay, so let's do 8 times 13. So 8 is minus 2 deviation, and 13 is plus 3. Now this is where it will get a little more complicated. So minus 2 times plus 3 will give you a negative 6. And 8 plus 3 or 13 minus 2 is going to give you 11. Okay. Now here is the tricky part. We are talking about base 10, remember? So this minus 6 has to be taken out of the base 10. That is, if I write 10 here, so 10 minus 6, that is 4. And just like you do any other calculations, subtraction, because I've taken a 10 here, I need to take 1 out of this. So this becomes 10. So your answer is 104. This may take a little while to digest in, but I can assure you that the method will be really helpful if you perfect this. Okay. So base 10, we have done three examples in base 10. I can see one raised hand. Let me see if there's any fresh raised hand here. I don't know if Arun has raised hand now or earlier. So let me just make all hands down. And in case you have any question, please raise your hand now. Any questions? I hope you can all see my screen with the 3 examples. Yes. Okay, I can see one raised hand, and let me just quickly pass it on to Devapriya. Or Devapriya has already had one chance. Let me pass it on to Naushaba. Okay. Here you go. Yes. Any question, Naushaba Hayat? Any question?
Sir, please explain once again.
Okay, the whole of it or the last one?
Last one.
Last one. Okay. All right. All right. Let me go through it again. The last one is a little typical, so I guess it needs a bit of explanation. I'll just go through this again. Maybe I should just erase it and try another one. Okay. Oh, in fact, I can just erase everything and then start fresh. All right. So let's do this one again. I guess the typical one is that of a plus and minus. So let's do. We are talking about base 10. So let's say 9 times 14. Okay. We are talking about base 10. So we need a deviation here. Base is 10. So the deviation in case of 9 is minus 1. And in case of 14, it is plus 4. Right? I hope you can follow this. I'll activate your microphone as well. In case you're not able to follow it, please stop me wherever I am. Okay? All right. So we are talking about 9 and 14. 9 has a deviation of minus 1 and 14 has a deviation of plus 4. The product here will be 4 times minus 1, that is minus 5. Okay. And then you can do either of these calculations, 9 plus 4 or 14 minus 1, and that would give you 13, right? Now, since there is a minus sign here, we need to subtract it from something, right? And we are talking about base 10, so we'll put this 10 here. Okay. So 10 minus 5 will give you 5. But this 10 has to be borrowed from here, right? From 13. So we'll have to borrow 1 from here. You remember your subtraction method anyways. The conventional subtraction method also works like this. So you need to borrow 1 from here. So this would become 12. All right. Oh, I'm sorry. I think we did one error here. This should have been 4. I'm sorry. This should have been 4. Right? 4 into minus 1, that is minus 4, right? And then 10 minus 4 is 6. Okay? So 126. I'm sorry. That was a small error. Alright? Did you understand this now?
Yes.
Alright, perfect, perfect. Thank you. Okay, there's another one example with from 4-digit number. Now 4-digit number obviously would require a larger base, okay? So maybe I think we should do a more unconventional base, okay? Let me just go step by step and let's do one more problem on a slightly larger base. So let's talk about base 100, okay? We can obviously go on to base 10,000 as well, but let's do a base 100 first. And let's do a typical, instead of going through all of those again, let's do 104 times, let's say 112, okay? So this is plus 4 and this is plus 12. The right hand side is 12 times 4, that is 48. And the left hand side is 104 plus 12 or 112 plus 4. Both of them are going to give you the same answer, that is 116. So this was a fairly straightforward question, 116 and 48. In case you get a 3-digit number here on the right hand side, please remember to carry forward the 3rd digit onto the left. Okay, that's how it happens. All right, so let's take a slightly different example. Maybe we should take another positive and negative. Okay, so 102 times 97. 102 we know is plus 2 and 97 is minus 3. Again, we land up in a negative situation here. So 2 times minus 3 is minus 6, and 102 minus 3 or 97 plus 2. Of course, all the addition is simpler. So 97 plus 2 is easier and it will give us 99. Now you remember that we are talking about base 100. Please don't confuse this with 10. You should not write here 10 because we are talking about base 100. So 100 minus 6 is 94. Now remember, we have to borrow 1 from here to give this 100. So I must get a 98 here. So 98, 94 should be my correct answer. Okay, you can check this out and try it yourself. More numbers. I think we can just quickly move on to a slightly different kind of base. All of you must be wondering, why am I taking only 10 and 100? Let's take a slightly unconventional base. Let's do 200 and let's see how different it is. Okay, so base 200, you can actually do base 200, base 50, you can do base 25, you can do base 20, anything. But let's try base 200, okay? And let's take up a slightly typical example again. Again, a plus minus. Plus minus, I think, is the most confusing one here, so I'll take another one. I see one, 628 times 546. You would have to take a base of, I see Thankaraj giving me a problem which says 628 times 546. So you would have to take some base as 500 probably, but the calculations would be as daunting as this one, because you would get a deviation itself of 128. Okay, so let's stick to this for the time being. Let's do a simpler one. Maybe you can try it out at your leisure. Let's try to do 203, which is a plus 3 deviation, and let's take a negative deviation, let's say 199. Okay, this is minus 1. Now, please look at this carefully because we are talking about 200, not 100. Okay, this is just for the record, this is 100 times 2. Okay, so base 100 times 2. Now, this 2 is going to be a very critical contributor here. Now, 3 times minus 1, that is minus 3. And I told you that you need to have as many digits here as there are number of zeros in the base. So number of zeros is 2, so I must write minus 03. Okay, and of course it's fairly easy to do. 199 plus 3, that is 202. Now comes the tricky part. What you need to do is, now there are several ways of doing this. You can actually take 200 here and subtract 03 from 200, and then whatever you get here you can carry forward and then double. Okay, so let me try out a simpler way of doing this. let's first double this. Now why am I doubling this is because of this number 2 here. 200 is 2 times 100, so I have to double this, and I get a times 2, so I get a 404. Please don't double the right hand side, you only need to double the left hand side. That is very critical. Now 404, now effectively when I have doubled this, then I can go back to my base of 100 and subtract 03 from 100. Of course, there are other ways of doing this. I would prefer this way. It's a little less confusing. So I get a 97 here. Now remember, you've taken 100 here, so you need to subtract this 100 from this 4. So your answer would be 40397. Again, it is definitely not as easy as it appears to be. You'll have to do a lot of practice before you try it out on your students or your colleagues. Okay. Please don't try to get into a class without much of practice on this. It will be a little embarrassing. So I would suggest that you should go through these examples again and see, get more and more practice instead of just jumping into it. Okay. Let's try to do one more. I would have loved to do a 4-digit thing, but I think more importantly, let's try to do unconventional bases. Okay. So we have done a base of 200. Let's try to do a base of 50, which is half of 100, and let's see how this changes. So 50 is 100 divided by 2. Okay. Again, just as I said earlier, this would change the way calculations are done. Again, let's do a plus minus because that's the most complicated problems. So 49 times let's say 52. Okay. Again, we would get a negative. I am concentrating on negative ones because these are the most confusing ones here. Both negative and both positive anyways give you a positive number, so let's not worry about that. So minus 1 times plus 2 will give you a minus 2. Again, we are talking about 100 here. Okay. So you must write 02 here. Another way of doing this could have been base 50 is 10 times 5. So you could have done 10 times 5 as well. You would have got the same answer. You can actually try it out parallelly. If you're taken, instead of 100 divided by 2, if you're taken this as 10 times 5, it would have worked perfectly well. There is absolutely nothing wrong in it. In fact, just as we did 200 and multiplied it by 2, here you would have done with base 10, you could have multiplied it by 5. But let's focus on division just as a matter of seeing how different would it be. So you get 49 plus 2, that is 51, or 52 minus 1, that is 51 here. Now comes the tricky part. What do you do with this 51 and minus 02? Instinctively, it seems that we need to divide this by 2, right? 51 divided by 2. So 51 divided by 2 will give you 25, and there'll be one balance. Now, fortunately, since there is a negative here, you already anyways need a need a number here, right? Now, instead of dividing it by, had it been 50, there wouldn't have been any problem. But now we have 25 because 51 is not a multiple of 2. So you're getting a 25 and a spare 50. Okay. So this one, the spare one, actually goes here as 50. Okay. And you get a 48 here. So your answer is now 2548. Again, as I said, this is a little confusing when you're talking about non 10, 100, 1000 bases. It's a little confusing. 1000, 10,000 is fairly easy, but when you're talking about multiples or factors of 100, it becomes a little confusing. Please concentrate on this. I can probably repeat this again just to make sure that you've understood this. And I'm taking the most typical examples where you get a negative. Okay. So we took 49 times 52. 49 was a minus 1 deviation and 52 was a plus 2 deviation. Minus 1 times plus 2 would have given you a minus 2. I wrote a 0 here, 02 here because we are talking about base 100, which has 2 zeros. Okay. And on the left hand side, you get a 49 plus 2, that is 51. Right. Now 51 instinctively I know that I need to divide this entire thing by 2 because 50 is 100 divided by 2. So 51 divided by 2 is going to give you 25 plus a balance of 1. Now this 1, when it goes to the right hand side, actually becomes the base, that is 50. Okay, so that is how you get 50 minus 2, that is 48. So combining these two things, you get a 2548, 2548. I hope we have done the right calculations. I can see a raised hand here. Devapriya, should I pass it on? I'll activate your mic, Devapriya. Is there any question you have in mind? Hello? Okay, let me proceed. I think there was some, by mistake maybe. How would you multiply with base 25? That's a very nice question. Smita asked me, how do you multiply with base 25? So if you have a base 25, okay, let me just, if I'm not going to do an entire calculation, but if you have a base 25, basically you can do 100 divided by 4, okay? So then you would divide it by 4, all right? Of course, this particular example will not hold true if that's what you meant, because 49 and 52, if you take 25, then it becomes as good as the original problem. So for base 25, if you want to practice, I would suggest you could take something like 22 times maybe 31, okay, and you try this out. So divided by 4, you'll have to do this division at this point of time, okay. I think we'll have to move ahead, and you know, there are a lot of things that I want to talk about, but since we don't have enough time on our hands, we'll just move ahead. I hope we can handle these questions. Even otherwise, I'll give you my email ID. In case you have any questions, you can obviously shoot an email to me as well. But this is no rocket science. I'm sure once you get comfortable with the bases, you will find this is really easy. Okay. All right. So let's move ahead. Most importantly, why should you teach Vedic maths today? You know, there are so many things available in the world today. There are so many scientific calculators. Anybody who is doing engineering no more needs slide rules. He can resort to all sorts of scientific calculators which can do fantastic stuff. Why do you want to do Vedic maths today? Apart from the things that are mentioned in point number 1 and 2, there is a lot of scope in higher mathematics as well. For anyone who is interested in higher mathematics, this is extremely useful. In fact, most of the computations that are involved in today's computers is actually dependent on the base system that originated from Vedic math. Okay. More importantly, I think anyone who wants to figure out how these things happen, it will give you a very, very deep understanding of math, how math works. Because base systems, whatever we have talked about, this is not magic. This is based on very sound mathematical principles. So it will give you a very, very sound understanding of mathematics. It will also develop interest in children, because children get daunted by some multiplications, you know, and if you can tell them that there is a simple way of doing 375 times 11, and you show them the Trachtenberg way of doing it or the Vedic math way of doing it, they'll be thrilled, because this is something that is beyond them when they are still on tables. Okay, so this is very useful to generate a lot of interest for math in children. Of course, all of you might be aware that examinations like CAT or MAT or BPA, hotel management, all of these exams are aptitude exams, and they invariably have a mathematical aptitude and reasoning test section. And none of these examinations, at least for a few years more to come, I guess they won't allow a calculator to be taken into the examination room. Obviously, when calculators are not allowed, you need to be very, very quick with your calculations, because these exams demand a lot of quick attempts. So typically, you might have to do one particular math problem in less than maybe 15 seconds or 30 seconds. It would obviously help a lot if you know some of these methods. Okay, so you can pinpoint this particular point to your students so that they can generate more interest in Vedic math. And of course, finally, I'm really proud that Vedic math evolved out of India, and I have a lot of pride in the fact that the world came to know about this fantastic system through our own country. Okay, I guess Tankaraj is asking, how do you use Vedic math in geometry? We have only discussed very elementary stuff in Vedic math. Actually, Vedic math is made up of 16 sutras, that is 16 shlokas that are available presumably in Vedas, but there is a lot of debate on whether Vedic maths are actually related to Vedas. There is no evidence in Vedas that these 16 sutras exist, but whatever be the answer to it, for whatever we have covered in these last few minutes, we have just touched the tip of the iceberg, so to say. There are a lot of sutras that we haven't covered. We have covered probably 2 or 3 of them. For the trigonometric applications, you will have to use the other sutras that are available. All right. I suggest I'll give you that link that that could explain more details about Vedic math sutras. I hope that answers your question, Tankaraj. I'm sorry we couldn't really cover much of it in this session, but we'll try to do more advanced stuff later on, or maybe I'm sure you can get through to the Google pages when you want to do more stuff here. All right, points of discussion in your class, and for this again, the links that I would be giving you would be very useful for discussion. Did Vedic math actually originate from Vedas? This is a debatable question, and a lot of debate has been happening. Is it really mathematics? I mean, you can't call 12 into 13 as mathematics, and that's where application of Vedic math in trigonometry or calculus would put this particular question. It would answer this particular question very well. What are its applications in modern science? So you can ask your children to find out how these methods are used in modern science and IT. And finally, what are its limitations? There are obviously limitations to every system that we talked about. And these questions actually can also be put for the other systems that we have discussed. You can actually test QMON or Abacus on these same questions. All right, these are the different references that I have already referred to. The story of numbers is a very interesting watch on YouTube. You can actually watch it at your convenience. You'll find that it will generate a lot of interest to in your students as well. Science of mathematics in ancient India talks about how maths developed and how it influenced the study of science. Vedic maths, we have just discussed a couple of the points here, but you can apply to squaring, cubing, cube roots, square roots, and so on. A lot of stuff that you should be investigating more. All right, so towards the end of the session, this is the end of it, but I thought it would be pertinent to handle one question that I saw one question which said, can you please give one example from 4-digit number? So as I told you, the limitation of the other systems, but here we can do anything using this particular method. So let's do 4-digit multiplication by 4-digit. Let's do 4286 times, let's say, 3982. Obviously, with your calculators in hand, this is a matter of seconds. But can we do it using some general method of multiplication? Now, this method is not really only limited to Vedic math. This was also given by Trachtenberg. A lot of other mathematicians actually arrived at the same thing. Let's try and do quickly this kind of multiplication. Okay. Now, how does this happen? basically you can actually start from the right hand side as always. So what you do is, I'll keep on making some arrow pointers here. So when you have only the last digit to consider, the units place to consider, so this is how you would multiply. Okay, so 6 times 2, that is 12, and you'll keep adding, keep writing the carryover. Maybe right here, you can write it wherever you want to, but I'm writing it here. So I'm writing 12 as 2 here and 1 as carryover. Okay, so 6 times 2, that is 12. Now when you go on to the next one, you will have to take these two columns together, and when you have two things together, then you will have to perform the calculations like these. So what these indicate is that you need to multiply 8 and 2 and then 8 and 6 and then add them together. So 8 times 2, that is 16, plus 6 times 8, that is 48, and you add them together. So you get 48 plus 16 is 64. Again, as earlier, we need to write, oh, I'm sorry, we forgot the plus 1 carryover. This plus 1 has to be added to this. So you get 65. Of this 65, you would write 5 here and carry over 6. All right. Now when you come to 3, so you will keep moving like this, 1, 2, 3, 4. When you come to 3, the appropriate diagram is multiply the extremes and multiply the middle one. So this is the appropriate diagram for the 3. So basically what you're now doing is, let me use a different color. Okay, so when you're doing groups of 3, you would do 2 times 2, that is 4, plus 9 times 6. 9 times 6 is 54. 54 plus 4 is 58. 58 plus 8, 8 times 8. So I'm writing this here just for convenience. 58 plus 64, and you need to add 6 to it as well. Okay, so this should give you 64 plus 6, that is 70, and 70 plus 158 is 128. Now remember, you need to take only the units digit here. So you get 8 here and plus 12. Take a breath and then try to do this yourself. Let me again do it. 2 times 2, that is 4. 9 times 6, that is 54. 54 plus 4, that is 58. That's what we wrote down here, 58. And then 8 times 8, that is 64. And we didn't forget to add this carryover, that is 6. So 64 plus 6, that is 70. 70 plus 158 is 128. And I wrote 8 here and 12 as the carryover. All right. Moving on, let me pick up a different color again. Okay. When we are considering all 4 together, I'm sure you would have figured this out by yourself by now. Multiply the extremes and then come down and multiply the 2 digits again. So it seems like something like this. Okay. So basically now you need to do 4 times 2, that is 8. 6 times 3, that is 18. So 18 plus 8, that is 26. Let me write this down here. And then you need to multiply these two numbers. 8 times 2, that is 16, and 9 times 8, that is 72. So 26, 16, and 72. Of course, you don't need to write this down here every time because that defeats the whole purpose. You should do it, all of this in your head. So all of this, 26, 16, 12, and 72. If you add them together, what do I get? Now you can club them together. 6 plus 2 is 8, plus 2, 10, plus 6, 16. So 6 here, and then you get 4 plus 1, 5, plus 7, 12. You should have done this in your head. I'm just trying to explain it here, so I'm writing it down. It's fairly simple when you try to do this in your head, because you're trying to do 2 numbers at a time, not more than that. Okay. Now, once we have covered all of this, now you start skipping things from the right where we had begun. So now we will consider only 428 and 398. Okay. I know this is going to be a little tedious, but this is very interesting when you show it to your children how to do it. So we are talking about 428 times 398, and you know the appropriate figure, multiply the extremes and multiply the middle column. So we are talking about 4 times 8, that is 32, 8 times 4, that is 24, 24, 32 and 18. Let me do this in the head instead of doing this here. We are talking about, let's try to do the other way around. 9 times 2 is 18, and I know I need to add 12, so 18 plus 12, that is 30. 30 plus 32, 8 times 4 is 32, so 30 plus 32 is 62, 62 plus 24. 62 plus 24 should give you 86. So I write a 8 here, sorry, and 6 here. I hope you're all with me. You haven't slept off. And finally, not finally, semi-finally, we are talking about the, let's do another. So now we are leaving out, this becomes easier. We are only 2 of them, 2 columns, 42 and 39. This must be very easy. 4 times 9, that is 36. 36 plus 8. I prefer to add the carryover so that I don't forget it. So 9 times 4, that is 36. 36 plus 8 is 44. And 44 plus 3 times 2 is 6. 44 plus 6 is 50. So I get a 0 here and 5 here. Okay. And finally, this is the easiest part. So you're left with only 4 and 3. So 4 times 3, that is 12. And 12 plus 5 is 17. Wow. Can you believe it? We all did this together. I hope you're all doing this as we were talking. That was a long one. You can actually use this multiplication method in your classroom and ask the children to do it together. It's a fantastic feeling when 30 of those children are with you all the time trying to do this kind of a calculation of 4-digit. Why just 4? You can take a mobile number of 10-digit and another mobile number of 10-digit and multiply together. That's the best part of doing this kind of a calculation in your class. Try it out in your class and I'm sure you'll enjoy this experience. That brings me to the end of it. I see one raised hand of Rahul. Needs a lot of practice to excel. I saw one comment. Let me just pass it on to Rahul. Is there any question? Please don't ask me to do this again. I don't have the time, neither the patience to do it again. Rahul.
Hello. Yes, gentlemen. Thank you very much for this detailed one. But yes, here we needed somewhere, some website where you can check in how to really see it again, to practice. It was very difficult to understand it.
I understand. In fact, as I told you earlier, there will be a recording of this session on YouTube. The link will be available on beyondteaching.com, and you will obviously get an email as a follow-up with the link available. But as I suggested, I don't think you should limit yourself to only these few problems. You should actually go and explore other links that are available on the website. All right?
Okay. Sure.
Thank you
and
so
secondly,
much. Yes, please.
Yeah. Any other time will be an opportunity to get in touch with you?
Yes, of course.
I'll give you the mail.
Yes, I'll share my email after this slide, and you can get in touch with me. Okay.
Oh, sure. Pleasure. Thank you very much.
Thank you so much. Thank you. Bye.
Thank you. Bye-bye. Yeah.
All right. So we are at the end of the session, and I guess I've just reached 8 o'clock, which was the scheduled time. Brought to you by Beyond Teaching. We do a lot of things for teachers. I hope all of you keep visiting the website beyondteaching.com. There are quite a few things that are being developed on the site as well. And in case of any queries, you can actually contact me. Oops, I'm sorry. Let me just write down my email ID here so you can note it down. Maybe I should use a darker color. One moment, please. Okay, so I'm going to write down my email ID here, and you can send any comments or any feedback on the session to this email ID, anirudh@beyondteaching.com. That's fairly simple. Please feel free to send an email with your feedback and comments on this email ID, and I'll be glad to handle any particular queries. All right. Let me just quickly show you that slide which had the email ID so that you don't lose track of it. It's anirudh@beyondteaching.com. Thank you so much for your comments. I can see quite a few comments that it was quite informative. I hope it serves the purpose of enriching your classrooms. This session was not really for students. It was more for teachers. I hope all of us were teachers here. Just in case there was a student, my apologies that we couldn't really go into details of it. But please go through the links that were mentioned earlier, and you can learn more about it. Just to end the session with what is in store for you next, March 22nd, that is next to next week, March 22nd, Friday, we have a CTET math section discussion. I hope you all know what is CTET, Central Teachers Eligibility Test. Oops, I'm sorry. Central Teachers Eligibility Test is conducted for the CBSE teachers, and this is a very important test for a teacher or a to-be teacher, and the last experience has not been very good. CTET exam is not really that hard, but because we are not prepared for it, the last CTET that was conducted in January had a fairly poor result. Only, I guess, less than 1% of the teachers actually qualified the test. So we thought that it would be appropriate to actually discuss the CTET paper. And since most of the teachers found problem in math section typically, we thought that we would start with math. Of course, we would try to cover other sections as well. All right, so you can keep looking at other webinars. We'll probably put in another webinar before the CTET math section, but the details would be available on the website. You would also get an email just like you would have got this time. That brings me to the end of the session. Thank you so much for attending. It is extremely encouraging to see so many educators, so many teachers interested in upgrading their knowledge and sharing their knowledge. Please don't forget to give us appropriate feedback, because that's what keeps us going. Thank you. Thank you so much.